Okay, so welcome to our unit on grade 9 applied algebra in our flipped classroom. So we're going to take a look at these videos, and as I said in class, it would be a great idea if you had your own piece of lined paper and you wrote down some of the definitions or at least tried some of the examples at the same time. Remember that you can always pause the video anytime you need, or you can also rewatch the video as many times as you need. Okay, so we're just going to start today with some basics in terms of the terminology in this unit. Okay, so our first definition is what we call a variable, and you've definitely seen and heard this before, and that is simply a letter used to represent a value that can change, okay? The most common, of course, used is an X. It could be a Y, it could be an M, it can be any letter of the alphabet, okay? And then we have what is called a term, okay? A term is a variable, okay, so a letter, and or a number. Okay, so for example, you could have something simple like 3x. It can be any number in front of it, and it doesn't have to just be one letter. It can be a y squared, an m to the 3. It can be any of them. Now, this number in front here, the 3, okay, in front of a variable is actually called a coefficient, okay? So this is the number, okay, by which a variable is multiplied, okay? So, for instance, this 3 is considered the coefficient, okay, of that particular term. Okay, and in algebra, we are going to combine all kinds of terms to create polynomials. So the terms are going to be combined by addition signs or subtraction signs, okay? And depending on the number, they do have special names. So if there's just one term, it's called a monomial. If there's two terms, it's called a binomial. If it's three terms, it's called a trinomial. And four or more, then it goes to the general name of polynomial. Okay, and like I said, these terms are connected by addition or subtraction signs. Okay, so that 3x is an example of a monomial. A binomial, we could take that 3x, and let's say we could subtract 5y squared, okay? Two different terms in that one. We have our 3x, we have our negative 5y squared, or subtract 5y squared. There are two terms there, okay? For instance, for a trinomial, again, it can have any different combinations, but let's try an x squared minus an 8x plus a 1, okay? Three different terms. We have the x squared, the negative 8x, and the plus 1. And you'll notice how I'm saying it, that it is actually the sign in front that belongs with the terms. So this subtraction sign belongs with the 8, this addition sign belongs with the 1. So it becomes a positive 1, and it becomes a negative 8. Okay, and then a polynomial is anything that has 4 or more terms. Hey, for instance, something like x cubed plus 3x squared minus 12x plus 6. I just made that up. Any 4 terms. They don't all have to have the same variable either. Any 4 terms. Okay, so that's a little bit of technology. It would be good if you paused the video and wrote a little bit of these definitions down so that you do remember them. Okay, so one thing to know when we write expressions is that we always write expressions in descending order of powers, is the proper way to say that, meaning we put the highest exponent first. So basically, I could give you an example, something like this, and we could reorder it into descending order, putting the highest exponent first. Obviously, the x squared is the highest. This is an x to the 1. And then the numbers by themselves are actually called constant terms, and they would go at the end. So again, this goes back to that idea that I was talking about earlier, where I said the sign in front belongs with it. So if I was going to write this in descending order of powers, I would actually take this 2x squared and move it to the front, but remember I said that this negative, this subtraction, which I'm now going to call a negative, belongs with the 2. So when I rewrite it in descending order, okay, it becomes negative 2x squared. The 5x is positive, so it's plus 5x. And then the constant term at the end is the 3. And that's a definition that we didn't have on the front page. So let's just make sure you know that this is called a constant term. Just a number by itself. Okay, and again, test yourself for a minute. This example right here is, of course, a trinomial because it has 3 terms. Okay, the coefficients in this term are negative 2 and 5. And then, like we said, that last term is a constant term. Okay, take a look at this next one. First of all, pause the video for a minute and see if you can write it in order of descending powers. And also tell me what kind of polynomial is it? What name would you give it? Okay, so hopefully you got that on your own. First of all, there's 2 terms. It's a binomial. Okay, if I was to write it in order of descending powers, I would take that positive 3x squared term and put it first. I don't need the positive if it's at the front. And then I would take the other term, the negative 4, and I would put it last. Okay, those are 2 terms. This is a coefficient. Okay, this is a constant term right here, the negative 4. Okay. Okay, and the last definition that we're going to talk about, a very important one, is what we call like terms. So like terms are terms that have the same exponents and the same variables. So if I gave you this whole example group, these are all terms. We're not putting pluses or minuses between them because we're not putting them into a polynomial. These are just a list of terms. Okay, let's see if we can identify some of the like terms. Okay, so I'm going to start just with the x terms in blue. Okay, so there's 2x. Can you see any of the other like terms that would be like it? It has to have the exact same variable and the exact same exponent. So how about this negative 0.4x? Okay, and just scan the list and see, are there any other x terms? And note the exponent on the x, it's imaginary, it is a 1. So that's all the x terms. Let's do another one. How about the y terms? So there's a 3y. Scan, let's see if there's any other like terms to the y. No other y terms, so no other like terms in this group. Okay, let's do another set. How about the 17? Those are just numbers. Those are constant terms. Are there any other ones that are like that with basically no variables, with no exponents? There's also the 345. Okay, there's also the negative 8. Okay, and then we have an x squared grouping. Okay, so we have 9x squared. Note, different variable, same variable as the ones at the top, the blue ones, but these ones have an exponent of 1. These ones have an exponent of 2. Are there any other x squared terms? I see this negative 6x squared right there. So that's a group of like terms. And then we do have one more group of like terms, and that is the xy terms. There's 3xy, there's 17xy, there's negative 5yx. So one thing to note here, of course, is that the order that the letters are written in doesn't matter. All of these terms have an x to the 1, a y to the 1, x to the 1, y to the 1, x to the 1, y to the 1. We're multiplying them together. That's why the order doesn't matter. Okay, so that's a little bit about terminology. We're going to practice identifying like terms and naming polynomials tomorrow in class. I'll see you then.